Alright, this is a review of Sig Figs. You guys learned this last year, so it should be a complete review, but I want to go over it just to make sure, because when I assume when you come in the classroom, you know about Sig Figs. So when we talk about significant figures, we measure things and calculate things a lot in chemistry, and really what we're trying to do is come up with a rule for rounding off numbers. How do we round off numbers in our answers? So we pay attention to Sig Figs. That's what gets us there. So first rule for significant figures is 1 to 9 is fine. That's what I like to say. What does that mean? Any non-zero number automatically counts as a sig fig. So for example, if I had 637, that number would have 1, 2, 3 sig figs because they're all non-zero digits. 71 has 2 sig figs, 2, 4, 6, 5, 2,465 we would consider to have 4 sig figs. So a key rule is 1 to 9 is fine. All non-zero numbers count. JL zeros. A JL zero counts, because really when you do sig figs, you're really trying to figure out whether or not the zeros count, because you know 1 to 9 automatically does. So when we talk about a JL zero, what does that mean? Well, if I had 607, I know from the rule above, the 6 and the 7 count because they're 1 to 9 is fine. That is considered a JL zero because it's trapped inside of two non-zero numbers. So we would say that counts as well. That has 3 significant figures. Same thing with 4008. 4008 basically is what you're looking at. Counts, 1 to 9 is fine. Those are JL zeros, so ultimately we would say that number has 4 significant figures. The third rule is the escape convict zero. Well, we talked about what a jail zero is. An escape convict zero is the exact opposite, and they do not count. So if I had a number that was like this, 607, so 6,070. I know the 6 and the 7 count because 1 to 9 is fine. I know that's a JL zero. That, on the other hand, is an escape convict zero because it's outside of the non-zero. It's not a JL zero, so automatically it means it's escape convict. So we would say this has 3 sig figs. This number right here, 33,000, has 2 sig figs. Why? 3 and the 3 count. 1 to 9 is fine. That is an escape convict zero, escape convict zero, escape convict zero. Therefore, 33,000 as written like that only has 2 significant figures. The last rule we get to is what we call the decimal rule. I call it the Beyonce rule. If you know Beyonce, right? The Beyonce rule basically goes by the idea that if a number contains a decimal, as soon as it has a decimal, then you just use the Beyonce rule. You look to the left, to the left, to the left, like the Beyonce song, and you find the leftmost non-zero digit. So we're looking for the key is the leftmost non-zero digit. Any zero on the right of that digit counts. Any zero on the left does not. What am I talking about? Well, talking about this. If we did we'll do 0.084070. We look at this number. The first thing I notice when I see the number is the decimal. It's got a decimal right there. So I have to find Beyonce basically. How do I find Beyonce? I find the leftmost non-zero digit. Where's Beyonce? To the left, 8 is Beyonce, my leftmost non-zero digit. Anything on this side? No, does not count. Anything on that side? Yes. Or in Spanish we say sí. Counts, which would be basically we know the 8 and the 4 and the 7 count, but these 2 zeros count, so this number has 5 significant figures using the Beyonce rule. So as soon as you see a number with a decimal, automatically look for Beyonce. Let's do another one. 60100.00. How many sig figs does that have? Well, the first thing I notice when I look at the number is it's got a decimal. So I'm going to use the Beyonce rule. The leftmost non-zero digit is going to be 6. No on this side. C on that side, which means that 0, that 0, that 0, that 0, and that 0 counts. The 6 and the 1 count. So you end up with 7 significant figures in that number right there. So that's the first thing you have to be able to do is identify sig figs. Now, if you look here, first thing I see, decimal, Beyonce is the 3. I know the 8 counts. That 0, that 0, and that 0 on the right. So therefore, this has 5 significant figures. I see the decimal right there. Bam. First thing I notice, I find Beyonce to the left, right there. The 4, 1, and 8 all count. That has 3 significant figures. What if a number is in scientific notation? You ignore the power of 10. It doesn't really, these are just placeholders, so it doesn't really matter. So I just look at the number 7.09 in the front. It has a decimal, so I find Beyonce, which is the 7, which means it has 3 significant figures. Look at this one. This one has no decimal, so what we're looking at right here is we have 2 escape convict zeros, which we know don't count, and the 9, 1, and the 6 count, so that has 3 significant figures. I see the decimal, I find Beyonce, that 0 and that 0 count, it has 4 significant figures. I notice here I'm going to ignore this. I see the decimal, there's Beyonce, counts, 4 significant figures. I look at this number. This says an escape convict 0, doesn't matter, so total we have 2 significant figures there. So 250, we don't really cross out the 0, I'm just doing this as an example purpose, so you can get the idea of it. Now, when we actually do the math, how do you apply the rules? Well, if you ever multiply or divide something in chemistry, like here, 278 divided by 11.70 gallons, right? When you're doing that, what you do is you find the number of sig figs, and it's the least number of sig figs. So it's the least sig figs when we're talking about multiplication or division. And you have to pay attention to what you're doing. So if I look here, 1, 2, 3, it says right there, 3 sig figs. This is a decimal, Beyonce, 0 counts, 4 sig figs. Since the numbers going into my calculator, the smallest number is 3 sig figs, when I get the answer, I have to round off my answer to make sure that I have 3 significant figures, which 23.8 does. Now, the only other key thing that you're going to do is you're either going to add or subtract. When you do add or subtracting, it's least decimal places. So we're talking about least decimal places. So when you go and do that, you look right here, 3.18 has 2 decimal places as listed right there. 0.01315 has 5 decimal places. Well, 2 is the smallest number, so what's going to happen is when I add this number in my calculator and I get my answer, the answer can only have, when I write it on my paper, 2 decimal places. So I round it off to 2 decimal places. So when we do addition or subtraction, you use least number of decimal places. When you do multiplication or division, you use least number of sig figs. I'll put a sheet on at Moto that will allow you to review this. All this should really be review, but it's good for you to watch this ahead of time, because in the summertime you have a tendency to sometimes forget that stuff. All right? See you soon.